Hi, welcome to Agglomerative Hierarchical Clustering. This is based upon complete linkage metric. The complete linkage in the sense it will use the maximum distance between the two data points I and j, which are belongs to two different clusters, cluster 1 and cluster 2. This is the method widely used to form tighter clusters than single linkage metric based clusters. Here the data points are given, four data points, 1 comma 1, 2 comma 1, 1 comma 3, 7 comma 1. Then we will calculate the distance matrix by using the Euclidean distance. Here initially we are considering all the four data points are single tone clusters. That means each cluster is having single data point, so four clusters are there. Now we will apply the Euclidean distance metric to calculate the distance matrix. The distance between 1 comma 2 data point 1 comma 2 1 and which is done. Now 1 comma 3, so 1 comma 3, here we are calculating 2, then 1 comma 4, the 1 comma 4 is here, we will get 6, and 2 comma 3 2.23, 2 comma 4, the 2 comma 4 data points distance is 5, and 3 comma 4 3 comma 4 data points distance is 6.32. Now we will fill the data in the distance matrix. So four data points in the rows and four data points in the column. Now we will fill the diagonal values, the distance between the cluster itself, right? So the distance between the cluster itself is always 0. Then the distance between 1 comma 2 is 1, distance between 1 comma 3 is here 2, and distance between 1 comma 4 is 6, and distance between 2 comma 3 is 2.23, and distance between 2 comma 4 is 5, and distance between 3 comma 4 is 6.32. Now these same values will be reflected in the upper portion of the distance matrix, upper triangle of the distance matrix. Look at that, 2 comma 2 is 0, so here 1 comma 2, 1 comma 2 is equal to 2 comma 1, this value 1, and like that, 1 comma 3 is same as the 3 comma 1, so it will be a 2, and 1 comma 4 is equal to 4 comma 1, so 6. So same values are reflected once again, so we can ignore this portion. Now from this distance matrix, select the minimum value. So here among this given distance matrix value, 1 is the minimum value, so you select that is the close cluster to this to this cluster 1. So this is the data points, two data points are close to each other, that means 1 and 2 are close to each other than these two data points. So now we are going to combine this p1 and p2. So now for we have to combine this p1 and p2 by selecting the minimum distance 1. So after combining, update the distance matrix. So when you are updating the distance matrix, we should use complete linkage. The complete linkage in the sense maximum distance between the data points. So after combining cluster 1, cluster 2, cluster 3, so now we have to identify the distance between this combined cluster and individual data points. So now we have to update this column of the combined cluster and row of the combined cluster. So now the distance between 1 comma 2 and 3 we have to calculate. So data points, this is the cluster 1, cluster 2. So now the distance between these two, d1 comma d3 and d2 comma d3. So now d1 comma d3 is here 2, right? So that is written here, and d2 comma d3 here 2.23. So the maximum value we have to consider because of complete linkage. Then maximum value is 2.23, so that will be written here d1 comma d2 comma t3, so 2.23. Then update the distance, this cell valued 1 comma 2 to 4, so d1 comma d2 to d4. So here for that we have to calculate d1 to d4 and d2 to D4. So D2 to D4 is here the 5, and D1 to D4 is 6. So the maximum between 6 comma 5 is here 6. So 6 will be written here. Now after updating the distance matrix, we should identify the diagonal value of 1 comma 2 to 1 comma 2. The distance between cluster itself is here 0. Now select the minimum value. So here, after computing that, updating the distance matrix, again find the minimum value. So the minimum value is indicating the closest data points in the two different cluster. Here cluster 3, cluster 1 comma 2. So here these two are very close to each other. Then so here the fourth cluster is very large, sixth data point. Okay, so we have to select the minimum value. So minimum value close to each other. So now we will combine data point 1 comma 2 and 3. So after combining, so 1 comma 2 comma 3, both 3 are combined. So these two clusters are formed earlier. This is one cluster, this is one cluster. Now both are formed, both are combined together. Now after combining, we are going to update the distance matrix. So here D1 2 3 is combined and D4 is there. So now we have to identify the distance between these two clusters. So this one, right, fourth data point and this cluster. Okay, so we have to identify the distance between these both clusters. So for that, we have to identify D1 to D4 and here D3 to D4. So D3 to D4 is here 6.32, that is given here, and D1 to D4, D1 to D4 is 6. So 6 comma 6.32. So maximum of these both values are 6.32. So 6.32 will be written here. This is the distance between this cluster and D4th cluster. So then diagonal value, the distance to cluster itself is 0. From this distance matrix, we have to select the value. Here the minimum value, only one data point alone available, 6.32. The 6.32 will be selected, and here already these three are combined. Now this is only available, so we will combine all four data points into single cluster. So now all four data points are clustered. After this, now we have to identify the dendrogram, tree-like structure. So initially we have combined P1 and P2 with the distance value 1. So the distance value 1, we have combined the P1 and P2. Then we have combined the this P2, P1 and P3. So now look at this. This is one cluster and this one is another cluster. So both are combined with distance 2.23. So here approximately 2.23. Then next, this 3 are in cluster and P4 in another cluster. So we are combining this one and this one. So now that is the distance matrix 6.32. So approximately it is 6.32. So like this we can apply the hierarchical clustering to cluster that individual data points into single cluster in bottom up approach. Thanks for watching.